Hey guys, welcome back to my channel and I hope you are all doing great. This is lecture 3 on linked list series. I already covered lecture 1 and lecture 2. In lecture 2, we perform the insertion operations on a single linked list. And in this lecture, we are going to see how we can delete a node from a single linked list. So before watching this video, I request you to please watch my lecture 1 and lecture 2 so that you can able to understand things in a sequential manner and it will help you to understand the series in much better way. Without further delay, let's get started today's session. And this is the class which I created in my lecture 2. So please do watch that before coming to here. Now today we are going to see delete a node from beginning of the list. Let's try to understand in a diagram. And here is delete a node from beginning, right? Delete a node from beginning of the list. Assume this is my list 1, 2, 3, 4 and 5 and 5's next is null. Okay, my head is pointing to node 1. Okay, if I want to delete this 1, so delete from beginning is nothing but we need to delete this node and our head should point to this. That's all. That means we need to break this link and our head should point to this so that this new thing will become a node list. Okay, this is how we need to do. So how we can achieve this? If we carefully observe, it's all about moving your head to the next node and unlinking this one, right? Only two operations we need to do. So how we can perform these things? First, take a new reference which should point to the head only. Okay, let's assume I am taking some temp. Okay, and temp and head both are pointing to node 1 only. Okay, then what I need to do? My head should be temp.next, right? What I mean by that, so what's temp.next to? So my head is pointing to that, then just give temp is equals to null, so that what happens, its next is going to be null. That means there is no link. Okay, and when this is pointing to null, so no reference is pointing to this object, then in Java garbage collector can take care of this. Okay, you no need to worry on that. So these are the only two steps you need to perform in order to delete your node 1. But what if your list is empty, right? If your list is empty, that means there is no node in the list. Then you are not supposed to perform any operation, right? Because when there is no node, how you can able to delete? Just return null or else do nothing. Okay. What if you have only one node and its next is null? This is also one base condition like this. So you just check if your head next is null, that means there is one node, and just define head as a null. That's all you need to do. Let's see in a code. Void delete from beginning. Okay. The first condition is if head equal to null or head dot next is equal to null. That means if there is no node in the list or else there is only one node in the list, in that case turn your head to null and just do return. That means you are not doing anything. If this is not the case, this is not the case, then node temp is equal to head. Okay, that means your temp and head is going to point to the same list now. Then your head should be temp.next. Okay, and your temp should be null. That's all. And if you see my lecture 1, so where I took a variable size, so the intention is like whenever we do insertion, we need to increment it. whenever we do deletion, we need to decrement it. Okay, that is how we did in lecture 1 also. Like if I'm doing insert at beginning, I'm incrementing. Okay, and here I'm deleting a node. That means I should decrement the variable. That's all. So let's see how we can call it. Yeah, system.out.println delete from beginning, then obj dot delete from beginning, and then obj dot print list. Print list is nothing but it is going to print all your node values. Okay, let's run it. It is taking some time to get it built. Yep, if you see here, these are things are there till my last lecture. Okay, so where I inserted a node at a given position, and if you see, this is how my list was looking after performing that insertion operation. So you can see my head is 12 at the time here, current head. But now after performing the delete from beginning, you can see 12 got removed because like we deleted that. Then your head became 6. So this is all about delete at beginning. Now we perform delete it again, delete at end. Okay, let's understand in a diagram. This is second operation, delete at end. Okay, if my list is like this, 4, 5, and its next is null, and my head is pointing to 1. Okay, how you can perform, how you can delete this node? Delete at end means you need to delete this one, right? And as I said in my lecture 1, so in linked list, you won't get the facility to access a node randomly because this is not a like not a data structure like arrays, okay, where you don't get facility of having the indexes. The only thing is you need to traverse, complete this list, and you need to remove. Okay, but how we can do that exactly? Let's do one thing. So we are going to take a pointer, a reference prev, which is initially null. This is node reference, and we are going to take curve, which is going to point head. So initially how this look like? So my current is going to point to C. I'm denoting with a small c. Okay, this is my curve. So my curve head is pointing to same. Okay, but my prev is pointing to null. Then we need to see if there are no nodes. Okay, the base condition still remains the same like how we did in inserted beginning. If there are no nodes or only one node in the list, then your head should point to the null, and then you need to do nothing, right? This is the base condition which remains same for this deletion operation also. But what if there are more nodes like this? Now the thing is, so every time what we are going to do here is we are going to iterate this completely till this condition. If c dot next is not equal to null, okay, and I will tell you why this condition. And I'm going to the next page, okay, and if this is my list 1, 2, 3, 4, 5, and 5's next is null, and head is pointing to here, and current is pointing to here, and previous nothing but prev is null initially. Okay, and I'm starting with that condition while c dot next not equal to null. Okay, every time if that condition satisfies, what I'm going to do, let's see. If c is 1, is c's next is 2? No, right? Then what I'm going to do, my prev is going to be c, and my c is going to be c dot next. Let's see how it is going to be here. So once next is not null, then what I'm going to do, my previous going to point here, and my current going to point here. Okay, after checking the node 1, then this is how my pointer is looking. Then my current at 2 is 2's next is null? No. Then my previous is going to be here, my current is going to be here. Is 3's next is null? No. Then my previous is going to be here, my current is going to be here. Is 4's next is null? No. Then my previous is going to be here, my current is going to be here. Is C's next is null? Yes. That means this is the node which we need to delete, right? Because the last node references is going to be null only. In this case, what you can do, just to do something like this, p dot next is equal to c dot next. That means this is going to point null references. So this chain was broken now, right? Then this node is now eligible for the garbage collection. So this is only one simple step you need to perform. Okay. I hope you understood the process. Let's get into the coding part. Delete at end. So void delete at end. The base condition remains the same. I'm just doing copy paste. If head equal to null or else head dot next is null, that means there is only one node. Then I'm pointing that to the null, then I'm doing nothing else. Then what we need to do? As I said, you need to have a previous pointer, right? And you need to have a cur pointer. So first have those things in the hand. Node prev is equals to null initially. Node cur node is equal to head. Okay. Why I'm taking cur node? I explained in lecture 1, and once again I am iterating through that because you need to traverse through the list, right? So if you go with only head, so every time head is going to change its pointing, and at the end of the list it is going to be at this position. Okay, and that is wrong. Head means it always should point to the first node only. So that is the reason we are taking a new reference of cur node, and then we are not touching the head. Okay, till which position we need to do? While kernode dot next is not equal to null, till this position. Okay, what I need to do? My prev node is going to be kernode, and my kernode is going to be kernode dot next. Done. So at last, okay, my kernode is going to point this 5, right? And at the time my previous is going to be at 4. Then what I said here, at last you can do prev dot next is equal to kernode dot next. That's it. And since this is a deletion, just do decrement here, size minus minus. Okay, that's all for this. Let's run it. Sorry, I forget to call this method. You won't get result. We need to call here, right? So just copy paste, and here delete it and delete it end. Great. Now let's run and see the output. Yep. If you see here, after deleting from beginning, this is how my list was looking. But now after performing delete at end, you can see this 96 was deleted, and you can see the list is containing only these elements. And size also decreased. So here it is 8 and here it is 7. Okay, so this is all about delete at end. Now let's perform the last operation. Delete at given position. Okay. Now let's try to understand that also. Let me take different pen. Delete at given position. Okay, let's assume this is our list. 1, 2, 3, 4, 5, and 5 next is null. And in lecture 1 I said I'm assuming these indexes, I mean to say, like I am assuming like my node 1 is index 0 and its index is 1, 2, 3, 4 like this. Okay. And here, if I want to insert a node which is at position 2, okay, what I mean by that? So I mean I want to delete this thing, right? Because this is the one, 3 is the one which is at position 2, okay, and position is 0 based. Now, how I can do? So, as usual, the base condition remains the same, okay. So, here there is a small change. If your position is less than 0, or if it is greater than size, then you cannot do any operations, right? Because if it is 0, that means it is out of this boundary. And if it's greater than means out of this boundary, then how you can perform an operation? So you're not supposed to do that. And what if it is a valid one? I mean, if position is equals to 0, that means the intention is to delete this node. If position is equals to size, okay, that means the intention is to delete this node. Okay. Now, if position is something 2, then what you going to do? You need to delete the element, the node which is at that position. The process remains the same, like we need to have the previous pointer, we need to have the current pointer, and the current pointer needs to traverse till the position where it is, but previous is going to be one step uh, ahead, not ahead, behind to the current. So whenever your current node at this and your previous is this, and just to break this link and point this to the this node. That's all. Okay, and you need to break this also because your current next should also be null. Okay, that's all for this. So let's get into the coding. Yeah, void deleted given position, and it is going to take one parameter like pos position. The first base condition is going to be if position is less than 0 or position is greater than size, then you are not supposed to perform any operation. Otherwise, you need to check few things. If position is equals to 0, that means the intention is to delete your node 1, right? Just do a copy paste of these things. Okay, what we are going to do, I'm taking one temp is also pointing to the head, so head is going to be temp.next and temp is going to be null. That's it, and just do return. If this is not the case, okay, then what we need to do? We need to have the two pointers, as I said, two references, I mean by it. Prev, which is going to be null initially, and a node car node is equal to head. Okay, and we need to iterate till which position? For int I equals 0, I less than pos, I plus plus. Okay, till that position, my prev is going to be car node. My car node is going to be car node dot next. Okay, once I reach to that position where my car node is pointing to the actual node of the position, then what I need to do? As I said here, your previous next is going to be your current next, and your current next is going to be null, right? For that, take a temp1, temp node is equals to cur node dot next, because you are going to assign cur dot next is null, right? So cur dot next, then prev dot next is going to be temp, and cur dot next is going to be null. That's all. Once you done this, just decrement the size. Yeah, we are pretty much done with this operation also. Let's try and see for different cases how it behaves. Deleted given position, and I'm giving 0 here first. Deleted given position, I'm passing as a 0. Okay, let's see. Great. If you see after performing delete at 10, this is how my list is looking where head is 6. But after performing delete at given position where I passed 0 as a parameter, now you can see 6 got removed and 1 became the new head. Okay. Now let's see for other case also. Deleted given position, let's give 2. Now let's rerun. Yep, if you see here, as I said, I'm assuming indexes as 0 to size, right? So 0, 1, 2, 3, 4, 5, and I'm passing 2. That means 2 needs to be removed. So here 2 is not the node value, it is index. Okay, and 2 is got deleted, and this is how my list was looking. And my we did a small mistake here. So when we are trying to delete a head node, we are just doing return here without decrementing the size. Okay, you need to decrement here also, and then you can perform the size return. So now let's see how it is going to work for the final case. So first run it, and if you see the new size is 5, and after deleting from position 2, now I'm going to give pause as 4, and let's see how it is going to be. 4, 4, and just run it. It should actually delete the last node. Crazy. You can see here, so I given 4, that means 9 is at 4th position, so it got deleted and new size become 4, and my head is pointing to the 1. So this is all about this video, and I hope you learned how we can perform the delete operations on a list. Thanks a lot. Thanks for subscribe to my channel. Bye bye.